In this episode of Finno-Ugric Machining, we are dealing with this. Actually this. And well, this is the infamous VFD Speed Modulator. Well, I made a video where I construct this one, but that was actually quite bad. It did not go into details, and it was not enlightening how this works. So, well, we do it now in a way that it's proper. So, first of all, we will construct it. I will show you some best practices on how to deal with these are actually really small. Yeah. How to deal with that kind of stuff. Oh, that kind of stuff, and how to keep focused. Okay, so let's go to my workbench and start constructing this animal. Okay, here we are. Here's the workbench, and well, what we have here is. First of all, what the tools you need to construct a thing like this. First of all, you will be needing good magnifying system because the components are really small. And then, of course, you will be needing some solder. In this case, it is 0.22 millimeters. It's really thin, but because we also have things like this to solder, this would be horrific to solder with that kind of solder. We also use this stuff which is like 3 millimeters, but it's just for the biggest joints we are making. Even though this looks like it would be clean, well, it has been sitting on my shelf and collecting carbohydrates there. So first thing I will do, I take a little bit of steel wool and then just gently wipe the surface so it will become a little bit less oxidated, and there will be a little bit less those carbohydrates. You don't need to use any solvents here, just wipe with that stuff. This steel wool is probably the best practice in this case. Soldering the big ones here, the connectors. Normally I would not do it that way, but in this case, because we are testing this as we go, I would like to have at least the connectors and maybe the programming. This is the programming connector put there, and yeah, it will be a little bit, well, it makes soldering some of the smaller components a little bit more difficult, but you can still do it. Okay, so let's put the programming connector there. And it's, if you look at the picture here, which is not completely in the picture, it's that one. That's the programming connector. And if we look into the schematic as well, where is my finger? There. So that is the programming connector we are now putting in there. The thing with these type of connectors is that if I just put it there where it belongs there, so it's not indexing it. And well, and when you put the actual connector from here, it might be too low actually. So the way I usually make this, I take some of these ribbon connectors, put it there, like that. And then when I put it against the plate, like this, as you can see, so then if I put this upside down, like that, it will be there. You can solder it. I probably use the middle thickness. This is 0.5 millimeters solder. But these connectors, there you are, need a lot of heat. 3 of these. That one is very powerful. And it becomes really hot. This one is in between, and this one is for the really small components. And the diameter of the tip is, well, it's 0.5 millimeter. So it's really tiny. So we take this one, and this soldering iron currently has no tip on it. What you do, you just put it there, push it all the way in, and you are loaded. And then I switch this thing on, and it's almost immediately hot. So I have here, I wipe it clean, and it's already like hot. So now I will solder. You see it? Yes, you do. In this case, we really need to warm up and then you put a lot of the solder here, and then I check that it's still, no, it lost the indexing, so I will warm it up and push at the same time, and now it's there. And it stays there. Then I check from the back side that there is also, in the back side, that there is also solder there. So, this side looks good, yeah, and that side good as well. Okay, so now we can get this off. Boom. And it's in the correct position, in a correct place. There you are. Next thing will be these two, which are going on the sides here. And well, these are pretty simple. You just put them into the holes. They are a little bit tight, so you have to wiggle them in. And the other side as well. Take good care that the terminals point outwards, not inwards. So, okay. We take the thickest solder we have, because these require quite a lot of this stuff. So what I do, I warm this from the other side. Please note that I'm not putting the solder into the soldering iron. I'm putting it into the connection. There you are. We will have a regulator. This is a regulator in the schematic. It is this component here, and there will be one surface mounted capacitor and one this is radial type capacitor. It's so-called OSCON. And then we have an inductor, which is 470 microhenries. This is for suppressing any interference coming from the VFD, because there is a cable which is going to the VFD, and it can emit some interference, and therefore you need to block them right away on the edge here. So let's see if I can find an inductor like that. So here we have it. That. Let's take one. There you are. 470 microhenries. And this one goes into that place, like that. I didn't have regulator suitable for that place. So I took my Dremel and made it suitable. So now it's just to put it there. And then we take the medium tip, plug it in, and there you go. And switch the thing on. You usually don't solder these components, but this tip is way under 300 degrees, and it will actually not destroy this component even if I put solder on. So I just put solder on this side. Now it did, and it's really hot now. So, and I also put some solder in here, in this pad. There you are. And then I will take my, this is titanium. This doesn't wet. That's the reason why it is titanium. So now we have it there, like that. There is solder under, and well, it's there. And now just the two legs. I don't put it the whole way through. That would be a mistake. Like that. That capacitor was that one. And this was the inductor. And now we have installed that one as well, and the next step will be this tiny capacitor here. So this is my stock of capacitors. These are surface mount capacitors, and the ones we are looking are there. So we take one out of there, open the lid, and then let's take one. I will show you, you very soon understand why you need a very good magnification on your glasses with this one. There is your component on the tip of the soldering on the pliers. So that's the component there. And now we just need to solder it. It is that one. And now we are going into the smallest one, putting a solder blob there. There you have a blob of solder. And now what I'm doing is that I grab it with these pliers. These are titanium. These don't wet. So, and these also are very poor thermal conductors. So it means that I can keep the component in place while I'm soldering it. And it's there. I can show it to you now. We have the capacitor there now. Then I just solder the other side, but it doesn't end here. You will soon see. I have manually soldered it in place, but there is a thing now, because I warmed it up and it cooled down. It means that there are some tensions around in this component. They don't break it right away, but after 3 years it will break. So therefore I warm it up and look that it starts floating. This is quite easy task to do. Usually these float quite soon. You don't need to. What also happens here is that the component will find its place. So now we have all the components that are needed for the voltage regulator. We have the connector, we have the regulator, and we have the inductor, we have the bulk capacitor, which is on the input side, and we have the output side capacitor in there. So we can test whether it regulates. What I have here is that I have connected this into my power supply. This is the minus and that is the plus. Well, they are both green, but you have to believe me that they are. Then I have my voltage meter I have also connected. This is on the minus and the plus is on my probe, which is, there is a steel needle. And now we put this into voltage range, 20 volts. Yes, you can see it. And then I can measure from this one. Well, it has something there. Now it's in 0, but let's put 1 volt in there. So now if I measure, I can find the 1 volt somewhere like there. Yeah. That pin I'm now pointing with this one has nothing. It should contain 5 volts. But since this is an analog regulator, it won't regulate, it won't pass anything through at 1 volt. So let's see, if I raise this voltage to 2 volts, like that, and then we measure it, we still don't have anything there. Do we have something there? No, nothing. 2 volts, not enough. Let's put 3. 3. 3. 3 volts. Let's see if we now have something in the output. Yes, we have 100 millivolts. Okay, now if I raise the input voltage, so let's see when it's at, this should stop. I'm slowly raising the input voltage and measuring the output of the regulator. It should stop somewhere around 5 volts. Now we are almost over 4. Now it's very exciting whether it works or not. 4.99 volts, and what do we have at this time? 7 volts on the input, and this is actually going to work on 10 volts. The VFD is outputting 10 volts from the output, so I adjust this at 10 volts, like that, and we still should have 5 volts here. 4.99 volts. Okay, so 10 volts in this side, and then we had this capacitor, and then this regulator is an active element, which is actually when this output reaches 5 volts, it stops, it starts to throttle, so to say. So it keeps the output at 5 volts. Independent of the load, as far as we are on the specified range, which is 1 amp for this regulator. So we are getting now 5 volts where it is needed in this PCB. This is a power supply monitor. This one is actually connected to microcontroller reset. It behaves in a way that when the voltage is below a certain limit, the output stays low, no matter what the supply voltage is when it's below that certain level. But when it rises to a certain trigger level, it will release, and the output voltage goes high. Yeah, there you are. It's those. In that compartment we have those. There you are. And then we need 1 capacitor. There. I have my resistors like this. These are also surface mount resistors and now 8.2 kilo ohms. And this should be 8.2 kilo ohms. And it is. You can see when they start to float around. Those three. And now what I'm going to do next is to test whether this power supply monitor is working. Okay, let's put like 3 volts here, there, about. Now, as specifications say, this should be in ground. It's 0. Then when I rise the voltage slowly, it should suddenly hop up. Nothing happened yet. I'm rising the voltage at the moment. Now it did it. Went to 4.8 volts. As I said, the limit for this is 4.8 volts, so I should measure the same 4.8 volts here. Yeah. And then, if I lower it down, it's about 4.5 or something like that, when it should go down suddenly, like that. And up, yeah, 4.8, and this should end up being the 5 volts. And yeah, this one works as intended, as designed. Isn't it? It's speed. So the technique on soldering these is to solder one leg first, then align it, and then solder the rest of the legs. And if you put this wrong way around, you are basically screwed. This one. And now if you look, one of the legs is soldered and the others are not. But it's in a correct orientation and in correct place. So now I can solder the rest of the pins. So now we are going to test this circuit here, and well, what I have done, I have first of all put all the components for this low pass filter here, and furthermore I have connected from my signal generator a signal to this point, and then we have oscilloscope on the output of this thing. Okay, and it looks like this. So here is our input, and on the screen you can see the oscilloscope. Let's put this a little bit, no, there you are. So this pin here is connected as the input. And now what we should do, we should actually let's lower the voltage on the input like that. First of all, we should measure what is the output range of this. We are having at the moment I'm measuring here. It's 9.37 volts. We are getting from the VFD. We are getting like 10 volts, so I will put quite exactly 10 volts here. So there you are. And now the output, this one, is dependent on the DC level on the input, so therefore we have this capacitor resistor. I'm feeding here in the corner. I can adjust the voltage at this point. So now I'm adjusting it, I'm raising it slowly, and I will actually adjust it up until I get to the roof of the output. Well, it's not 10 volts, it's less. We are lucky if we get 9. Well, it's 8.85 volts. That's the maximum we can get out of this thing. So, okay. So let's adjust it just to 4 volts. Like that. There you are, 4 volts. Okay, now we have 4 volts in the output, but it's DC. Let's put some signal there. Like that. Okay, now you can see in the oscilloscope that there is a signal. I can show you the original signal as well. When I raise the frequency of the input signal, which is the upper one here, it should actually at some point become less here in the output. And it should be dependent on frequency in a way that when I raise the frequency around, let's say, 200 Hertz, this is 200 Hertz low pass filter. So it means that when I raise this input signal frequency, I'm changing the frequency, I'm not changing the amplitude at the moment. So when I raise it to 200 Hertz, this becomes half, and that's actually the roll-off point of this low-pass filter. So now let's see if this is a better picture. Well, oh, there you are. So now I can raise it even more, and please note how this output becomes more and more like DC. And let's put even more here. We are now at 400 Hertz. No, 4 kilohertz. This is 4 kilohertz. And it's completely DC here. Nothing in the output. I can let's put this in AC mode so we don't go all over the place, and let's put a little bit more sensitivity into it. As you can see, there is nothing. It's now 20 millivolts, 20 thousandths of a volt per one division here, and it's about less than 1 millivolt. If you can see, the line is not bright, it's hairy. That's noise. So at 4 kilohertz, this has completely cut off any AC component from the output. So let's see how it looks if I turn this input into a square wave. Oh, nothing much, but same applies if I raise the frequency here. It will go down this like that. The lower the frequency, the more it outputs, and in the high frequencies there is nothing in the output. Okay, so I think our low pass filter is working as designed. in the table we have now, this is ready. It is, all the components are there, and I also programmed the chip. Since this is not a programming channel, yeah, really not. So, well, I might make a separate video about programming these kind of things, about C language, which I'm using here, etc. Well, but I believe it's not very interesting for most of my subscribers, especially. Okay, but anyway, now what we have here, I have connected here 3 potentiometers. One of them, this one actually, there is a oscilloscope picture. Now it's in 0 volts, and when I turn this, the voltage rises up to 8 volts. Because here in the screen each division is 2 volts. So when I turn it up, it's now 8, and now it's 0. Well, this is used, the output, which is this red wire here. This is connected to the oscilloscope. So this is used to control the VFD speed. Very simply. So with this one, in this setup you can use it as normally. But why do we have this thing here is this. This potentiometer is the amount of modulation. If I turn this a little bit, well, now you cannot see because there is nothing to output, but let's put it into the middle there. You can see it's going up and down by itself. And yeah, okay, this is the amount of modulation, if I put it to the full. So now it's going up and down. And this is the amount you can control with this potentiometer. Now there is nothing, and or you can do it like this, which would make the lathe go wild. But again, the VFD must be programmed so that it doesn't stop when you put this entirely down. Probably the frequency range is very narrow, which I'm using there. So this means that when I turn it fully off, so you can then adjust your speed normally, and then you can add some variation there. Well, okay, and you can also with the third potentiometer, you can change the speed. This is now very slow. Let's put a little bit more. So it adjusts it really slowly. So the actual speed, amount of modulation, and modulation speed. These are the 3 potentiometers. And actually everything happens inside the brain box here. And well, from my perspective, this is now ready as a component, as a whole component, as a module. So next step will be to start figuring out the switches. So, okay guys, this is now my girls as well. Okay folks, this is my now ready to be installed. I have tested it. The last thing was to put to see whether it switches all right. I have connected here some LEDs to indicate if there happens something. Now when I power it off, and then the first one is the stop switch. It doesn't do anything. But the next one does. It lights, if you can see, 3 LEDs light up, and when I pull this away, and then the other direction, 3 other LEDs light up. And furthermore, if I now have it powered on like this, like the switch was connected, and I disconnect the power, put the power back, nothing happens. You need to disconnect all the switches and then put back, and then it works. Yeah, so this is just a safety thing. So normally in a VFD, if you make it in a way that in a lathe the switches are not momentary, they are switched on. So, and if you push the plug in, it would start. And this is something I don't want. I want it to be so that if I plug it in, no matter what, in what position the switches are, it won't start until I put everything first in 0 and then intentionally start them. So this is why there is such a logic in this. And well, this is it. Well, so now you know what it takes to put one of these together. Well, it's sort of yeah, tiny work. The next thing I will do, well, I'm waiting for the lathe. It has delayed again. Now I have a delivery date agreed for that one. Hopefully now it's the final date. But yeah, so let's see what's next. Hopefully the lathe. But if not the lathe, then I'll always figure out something else to do. So till then, see you.